Welcome back. We were inverse Laplace transforms. We have done already 6 problems. We will start from the 7th problem now.
Seventh one is of the same form, completing the square, but with a minor modification. L inverse of 3s plus 2 by 2s square minus 4s plus 3. Denominator, as we have done in the previous 2-3 problems, 2s square minus 4s plus 3. It is a quadratic polynomial. There is a 2 coming along with s square. I don't have any formula which gives me 2s square, only s square should be there. So we'll try to put this 2 outside. So what we shall do is first we'll put this 2 outside. Based on s square and 2ab, we will complete the square, the third term. So I'll take a 2 common from both s square and 2ab forms. So 2 into s square minus 2s, I've taken a 2 outside, plus 3. Now inside this bracket with s square and 2ab, I'll complete the square. A square minus 2s, so it is of the form a square minus 2ab plus b square. 2 is there, a is this s, there's nothing called b, that means it should be 1, plus 1 and minus 1. A square minus 2ab plus b square, this will look like s minus 1 whole square. So altogether 2 into s minus 1 whole square, s minus 1 as it is, and plus 3 totally outside. We have not touched this 3 anyway. Then take a L inverse 3s plus 2. 2 is outside for this particular term. Then I'll take 2 common. All these terms, 2 is common only for this term. Take a 2 common for this 3. This becomes 3 by 2. So that all together may come out, 2 comes outside the bracket. It becomes 3 by 2. Then this 2 will take out of the L inverse. So it becomes 1 by 2. What is left? 3s plus 2 is as in the numerator. Is minus 1 whole square, 2 is outside. 3 by 2 minus 1 becomes 1 by 2. What next? First we have changed the denominator to a square plus a square form. Now it is a turn of the numerator. If there is a s minus 1 and I have to keep a s term, then that also should look like s minus 1. We have discussed this in the previous problem. So this 3s, I have to take a 3 common. So to take a 3 common, I will add and subtract 3 because I have to take a 3 common. So 3s minus 3 plus 3. Okay. And we have split the terms also. 3s I have taken it over here. 2 I have put it as a separate term, this entire Laplace transform. This by this fraction plus 2 by this fraction. 2 by this fraction is over here. 2 I have taken outside. With this half here, it gets cancelled. So this is done. Now with this 3s, I'll add and subtract 3. 3s minus 3 I'll put together. So that 3 when I take common, 3 into s minus 1 plus 3. So 3 into s minus 1 plus 3. Now this is s minus 1 and this is s minus 1. Okay, so what has happened now? Half is there for both the terms, which has got cancelled here. Half L inverse of 3 into s minus 1 plus 3 by s minus 1 whole square plus half. And we'll come to the second term here. There is no s, so I can't apply the formula for s by a square plus a square. I can only arrange for a. A is possible, only I have to multiply and divide based on my a. If I have to make it as a by a square plus a square, I should identify the a first. This is a square plus a square. So what is a? A is 1 by root 2. So that when you square 1 by root 2 whole square. So that's why I have multiplied and divided by root 2 A is 1 by root 2, so the division we have kept here and multiplication root 2 is taken outside. Go through this part carefully. So that this is a by s square plus a square. A is 1 by root 2, this is 1 by root 2 a square. 1 by root 2 whole square, that is 1 by 2. We'll come back to this first term. Again I have two terms in the numerator. I will split this fraction 3s minus 1 divided by the denominator, L inverse of that, plus 3 by this term. So that altogether this splits into two terms plus this term 1, 2 and 3 terms. So after splitting, this 3 is constant which can go outside. So in the first term 3 by 2, L inverse of s minus 1 by s minus 1 whole square plus half. Then in the second term I am splitting with this 3. Half is to be taken for both of them plus half into L inverse of 3 by s minus 1 whole square plus half plus this term as it is. I have copied here. A square I have here split it as 1 by root 2 whole square. We will slowly evaluate each of them. 3 by 2. This is of the form s by a square plus a square. A is not half. A square is half. A is 1 by root 2. So this is cos 80 formula. A is 1 by root 2. So this should be cos t. I guess this should be t by root 2. There is a shifting of minus 1. So I have a e power t. So 3 by 2 e power t cos. This is not 1 by root 2. Cos 80. 1 by root 2 into t is missing over here. Plus, now again this should be of the form a by a square plus a square. This 3 has nothing to do here, only a should be here. A is not 1 by 2, a is 1 by root 2. So 3 will put outside. So this 3 when it comes outside it becomes 3 by 2. As we have done here, a is 1 by root 2. So multiply and divide by root 2. A is 1 by root 2, so the division I'll keep here. Multiplication will take outside the bracket. So this turns out to be L inverse of 1 by root 2 is minus 1 whole square plus 1 by 2 written as 1 by root 2 whole square. Plus, I have already applied the formula here. Root 2 a by a square plus a square. So that is sine a t. A is 1 by root 2 sine a. T is to be added over here. T is missing. Sine 1 by root 2 into t. This becomes shifting with e power minus t. So that I have a e power t here. Combine all the terms. Rearrange, you'll get the answer. The next type of problem, we have now studied shifting property when it comes in the denominator. We have studied completing the square in the denominator. Next one is by partial fractions. Then I cannot complete the square, nor I can directly apply the formula to find the Laplace transform. So how to do that? How do I identify? Now this is not completing square because there are two quadratic, this is a quadratic and this is a linear one. I do not have a quadratic one to complete the square. It's already a square also, s plus 1 whole square. So in this case, we will use partial fractions. The entire fraction inside the L inverse, the question, the entire function, I will convert it into a partial fraction. Now we'll see the denominator. S plus 2 is a linear one, so a by s plus 2. S plus 1 whole square, s plus 1 repeated twice, so that When I resolve into partial fractions, this becomes b by s plus 1 plus c by s plus 1 whole square. These two terms come when there is a repeated term. S plus 1 is repeated twice. Resolve into partial fractions. 4s plus 5 and then come to a. S plus 2 is there. That is not there here. Is s plus 1 whole square. So a into s plus 1 whole square plus b. S plus 1 once is there. So in the entire common denominator, s plus 1, 1 is plus 1 is missing, s plus 2 is missing. Plus c. S plus 1 whole square is there. S plus 2 is not there. So plus c into s plus 2. Now we'll have to find the values of a, b and c. So what is the trick? I have to make the denominator 0 1 by 1 by substituting suitable values for s. The first denominator is s plus 2. So what should we add to make it 0? What should be the value of s to make it 0? Plus 2 is there. So I have to put a minus 2. So put s is equal to minus 2. Substitute s as minus 2. So 4 into minus 2 plus 5 equal to a into put minus 2. I have put minus 2 so that s plus 2 becomes 0. So this term will be 0. This term will be 0. Simplify. I'll get a as equal to minus 3. Similarly, the second denominator, s plus 1 should be made 0. So what is the value for s? S must be minus 1. Put minus 1 here. S plus 1 is made 0. Put s is equal to minus 1. Since s plus 1 is made 0, s plus 1 is here, so these two terms will be 0. Is equal to minus 1, 4 into minus 1 plus 5 equal to s plus 1 is made 0, a into 0, s plus 1 is 0, s is minus 1, so that is b into minus 1 plus 2. Simplify, we get the answer c is equal to 1. We've got the value for a and c. Now there is a third denominator, which is s plus 1 whole square. To make this as 0, I have to put s is equal to minus 1 because s plus 1 is there. That work we have already done. S is equal to minus 1 I've already put. But I've got the answer only for C. A is there, C is there, B I have no other option to do. So what should we do next? When I cannot do this, the method we have is substitute for A and B. We'll take this polynomial. Put A and C. C is what we have found out. A is minus 3 into s plus 1 whole square, s square plus b square plus 2ab plus b into, multiply these two terms, s square plus 3s plus 2. C I have substituted as 1 into s plus 2. Simplify this. What I have done here is we have taken all terms with s square together, s and the constants together. Let's identify what are the terms having s square. S square, the coefficient is minus 3, so there is a minus 3s square. S square, the coefficient is b, so minus 3, and b with s square, there is no other s square here, so minus 3 plus b into s square. Next, collecting the terms with s. There is a minus 3 into 2s, so that is minus 6 into s written here. There is a b into 3, so there is a 3b. There is a 1 into s. There is a 1 into s, so that is there is a 1 into s. Minus 6 plus 3b plus 1 into s. Next we'll collect all the constants together. Minus 3 into 1, minus 3. B into 2, 2b. 2 into 1, that is 2. After all this, now left side is a polynomial in S, right side is a polynomial in S. If two polynomials are to be equal, then the coefficients of the corresponding power should be equal. That means if there is a square on both sides, the coefficients of a square on both sides should be same. If there is a s on both sides, the coefficients of s. Similarly, the constants must be same. There is no s square on the left hand side, but there is a square on the right hand side. If there is no s square, it means that the coefficient is 0. So what we'll do is equate the coefficients of s square on both sides. I only want b because a and c is already there. B. The simplest one to equate is s square. So I will equate only the coefficients of s square. The coefficient of s square on the right hand side is minus 3 plus b. Left side there is no s square. That means it should have been 0. So that minus 3 plus b is 0. B becomes equal to plus 3. So we have values for a, b and c. Substitute these values of a, b and c. I've substituted the values. So the entire function we have converted into partial fractions. We have resolved into partial fractions. So we'll take the inverse Laplace transform on both sides. So this was the question we had. So when I take the inverse, there are 3 terms. Therefore, the inverse splits into 3 terms. And the terms are simple now. This of the form is plus k. So we'll take this minus 3 outside. L inverse of 1 by s minus 2. 3 outside. 1 by s plus 1. This is L inverse of 1 by s plus 1 whole square. This is a simple one. 1 by s plus k. This is the standard formula for e power kt. If this is a plus 2, then it will be e power minus 2t. Then 1 by s plus k plus 1, so e power minus t. 1, this is of the shifting property. 1 by s plus 1 whole square. Except for this plus 1, this is 1 by s square. If it is 1 by s square, then it is t. Because there is a plus 1 here, it becomes t into e power minus t. So simplify, this will be the answer. Similarly, a bigger problem with the partial fractions. There's a cube here. So before we proceed with the partial fractions, take the function, given function, take a s common from the numerator and denominator and cancel out this. So I'm left with 2s plus 5 divided by s square plus s minus 2. We'll split this into linear terms. So that 2s plus 5 by s square plus s minus 2. You can split this quadratic polynomial as factors s minus 1 into s plus 2. Like the previous problem, resolve into partial fractions. This is more simpler. A by s minus 1 plus b by s plus 2. So what we'll be doing is multiplying by s minus 1 into s plus 2 throughout, or in simple terms, we'll take only the numerator here equal to a into what is not there in this denominator. A into s plus 2 is not there. A into s plus 2. Sb into s plus 2 is there. S minus 1 is not there. Next, we'll have to find a and b. Term by term, we'll make it as 0. So substitute s is equal to minus 2. This becomes 0. So put s equal to minus 2. And put s is equal to minus 2 and get the value for b as minus 1 by 3. Similarly, I'll make this term 0. What should I put here? S value must be 1. Put s is equal to 1 in this particular line. I get the value of a as 7 by 3. Substitute for a and b here. A was 7 by 3. So 7 by 3 into 1 by s minus 1. b is minus 1 by 3. So minus 1 by 3 minus 1 by 3 into 1 by s plus 2. Take the inverse Laplace transform. This is my problem. Inverse will also split. So 7 by 3 comes out. L inverse of 1 by s minus 1. This is minus 1 by 3 into L inverse of 1 by s plus 2. 7 by 3 into 1 by s minus 2. It is minus 1, it is e power plus 2 plus 1 by 3 is plus 2, then it is e power minus 2t. This is minus here. Minus 1 by 3, minus 1 by 2, minus 1 by 3, minus 1 by 3. This is the answer we have for the ninth problem. Next we have a problem. Show that the inverse Laplace transform of s square by s power 4 plus 4a power 4 is 1 by 2a into cos h at sin at plus sin h at into cos at. This is also resolving into partial fractions and completing by square altogether. So we'll slowly do it one by one. S square by s power 4 plus 4a power 4. For time being, we'll not do anything with the numerator. This is s square whole square plus 2a square whole square. 2 when I square it is 4, a square when I square it is a power 4. So this is of the form a square plus b square. So what we will do is, there is already a square plus b square. I have to simply add plus 2ab or minus 2ab so that it becomes a square plus b square plus 2ab form. So already a square plus b square is there. I will add a 2ab and subtract it to b. What is a and b plus 2? A square, no? So a is square, 2a square whole square, b square. So b is 2a square. So plus 2ab minus 2ab. So this becomes a square plus b square plus 2ab, that is a plus b whole square. A is a square plus b is 2a square plus b whole square minus this, we will keep it as it is. So 2 here, minus 4 a square a square. So a square by a square plus 2a square whole square. The second term, can write it as 2sa whole square. 2 square is 4 a square and a square. So this is of the form a square by some square minus another square. A square minus b square. So a square minus b square, can write it as a plus b into a minus b. So in place of a, I have a square plus 2a square, this is a and this is b. So the term will be a plus b, which are into a minus b. A minus b is the first part. And complete the square, then we use a square minus b square formula and split it as a plus b into a minus b. The next step will be, now I have two quadratic polynomials. I will split this into partial fractions now. So I'll take this term. Now both are irreducible quadratic forms. So when I don't have a product of linear terms, x plus a into x plus b, when I have x square, I cannot split it. In that time, I will have in partial fractions as plus b plus cs plus d. If this was x, in x it is ax plus b. I will take this as the denominator and numerator will be ax plus b form. Since my variable here is s, this will be as plus b. Because this is irreducible, as plus b by the first denominator plus second term is also irreducible, so cs plus d by the second term. As we have done previously, s square equal to as plus b into what is not there in the denominator? This term is there, minus term is not there, so a square plus 2a square minus 2ac plus cs plus d. There's a minus term here, plus 1 is not there, so cs plus d into a square plus 2a square plus 2ac. Next, we'll have to collect all terms with s square s in constant. Note here, not only s square, there will be s cube also, because when I multiply these terms, s cube also will be there. So what I have done here, I've taken s square, the tick mark here. S square is here, there's s square here. I will take those terms first. So this will be as plus b into s square. This one will be plus cs plus d into s square. And I'll take terms with s here. S is here, s is here, which I've crossed here. So this minus 2sa into as plus b, minus 2sa into as plus b. S I have written last, that's it. Cs plus d into this term, 2sa into cs plus d, 2sa into cs plus d, only that s I have written later. Then constants, 2a square is here, 2a square is here, 2a square into a plus b, 2a square into a plus b, 2a square into cs plus d. Next I'll separate s cube. Look at here, s into s square gives me s cube. There is no s cube coming from here. S into s square gives me s cube. There is no s cube coming from anywhere here. This can give me only s square or s square or s. There is nowhere I will get s cube here. So the terms with s cube are as into s square and cs into s square. That means when I take s cube common, a will be left. When I take s cube common, c will be left. So coefficients of s cube are only a plus c. This is s cube, its coefficient is a. Multiplying, we'll collect the coefficients of s square. There's a bs square, so that is b. There's a ds square, so plus d, the coefficient is d. There's a square coming from here. We multiply these two terms, so the coefficient is minus 2 small a into capital A. Minus 2 small a into capital A. There's one more s square coming from here. Coefficient is 2ac. Then there are no s square this side. So altogether this will be my coefficient of s square. Then collect coefficients of s. There's no s here. S square, s square. S might come here from the second term. The coefficient of s will be minus 2a into b. Another s here. So this will give me s plus 2a into d. This is from when I multiply these two terms. So 2a square into a. This is when I multiply these two terms. 2a square into c into s. Then the constants. It's constant here and there is a constant here. b into 2a square plus d into 2a square. Next, equate the coefficients of the corresponding powers of s. I have s cube, s square, s and constant. I will equate s cube first. S cube, left hand side there is no s cube, so that the coefficient is 0. Right hand side the coefficient is a plus c. So a plus c is 0 or a is equal to minus c. Then I'll try to equate the coefficients here, which is the constant. There's no constant on the left. Right side the constant is this one. Take a 2a square common. 2a square into b plus d is 0. That is b plus d is 0 or b is equal to minus d. We have got a relation between a, b, c, d now. Still we have not got values for a, b, c, d. We'll equate the coefficients of s. There's no s on the left. That means it is 0. Minus 2ab plus 2ad plus 2a square a plus 2a square c is 0. I can take 2a common here and substitute for b plus d from here, or b I have substituted as minus d here, and a I have substituted as minus c. So when I simplify, minus into minus is plus, plus 2ad becomes 4ad, minus 2a square c plus 2a square c, that gets cancelled. So 4ad is 0, or d is equal to c. If d is 0 here, b is minus d, so b also becomes equal to 0. So here second term is 0, where the second term is 0, so it is a is here and c is here, only that we have to find a and c. So the next thing we'll do is we'll equate the coefficients of s square. I'll take from here, there is a square left side, so 1 will be the coefficient on the left hand side, 1 will be the coefficient from the left hand side. Right hand side is minus 2a into b plus 2ad plus 2a square a plus 2a square c. Sorry, a square, right? So b plus d minus 2aa plus 2ac. B plus d minus 2aa plus 2ac. B plus d we have found it as equal to 0. B plus d is 0 from here. Take a 2a common. Minus a plus c is 1. Minus a is nothing but c. So 2a into c plus c is 1. So this is 2c. 2c into 2a becomes 4ac equal to 1, or c is equal to 1 by 4a. A is minus c. So c is 1 by 4a. A will be minus 1 by 4a. B and D already it was 0. A is minus 1 by 4a. A into S was here. So minus 1 by 4a into S. C was 1 by 4a into S. This D was already we have got it as 0. So this term reduced into partial fractions. Next, the original function. The inverse of the original function is same as the inverse of this function. The inverse of this function is same as the inverse of this function. This inverse I can split it into two terms. When I split, I can take this minus 4a outside. L inverse of minus 1 by 4a into S by this denominator, plus L inverse of 1 by 4a into S by the second denominator, second term. So minus 1 by 4a taken outside, L inverse of this term here. This 1 by 4a taken outside, L inverse of this term. Again, we'll look at the denominator. S square plus 2sa plus 2a square. This is of the form a plus b whole square. A square is here. 2ab is here. I just want a b square. So s square plus 2ac I'll put together. A square plus 2ab. B is a. So b square will be a square. So I have a 2a square, which I'll split it as a square plus a square. Similarly here, a square minus 2ab minus 2ab. A is already here, b is a, that means b square will be a square. I had a 2a square, so that this 2a square I will split it into a square plus a square. So this is a plus b whole square now. So that minus 1 by 4a, L inverse of s by a is s, b is a, s plus a whole square plus this a square, plus 1 by 4a, L inverse of s by, this is a square minus 2ab plus b square, so a minus b whole square, a minus b, s minus a whole square plus a square. This looks like a standard formula, except that, what is the problem here? S has a shifting in the denominator. S has a shifting in the denominator. This is s by s square plus a square. If there is a shifting in the denominator, numerator also should have the same splitting. S plus a is here, so this should be s plus a. S minus a is here, this also should become s minus a. So I have taken this, so I have added and subtracted a here. I've also added and subtracted a here. Added and subtracted a. Added and subtracted a. This is s plus a, so I've kept s plus a together. This is s minus a, I've kept s minus a together. Now again I have to split this into two parts now. There are two terms in the numerator. So s plus a by this term, L inverse of it, minus a by this term, L inverse of it. Minus 1 by 4a is common to both the fractions I've split here. So minus 1 by 4a into, in the bracket, is L inverse s plus a by s plus a whole square plus a square minus of L inverse of a by s plus a whole square plus a square. Plus 1 by 4a, this also will split it into two parts. 1 by 4a is common when I split. L inverse of the first one plus L inverse of the second one here. Minus 1 by 4a into, now this is of the form with the shifting plus a, s by s square plus a square. So s means it becomes cos plus, so cos at plus a in case of a goes away, a here. And there is a shifting of plus a, so that is our minus 80. Minus of a by a square plus a square, that is sin 80. There is a shifting of plus a from here, plus a square is our minus 80. Plus 1 by 4a, s by a square plus a square, that is cos 80, minus a gives me e power plus 80. A by a square plus a square, that is sin 80 minus a square, so e power 80. We take 1 by 4a common. We take 1 by 4a common. What happens here? 1 by 4a together from all the four terms. I've taken all the terms here, minus, I've multiplied inside, minus e power minus 80 cos 80, minus into minus, second one becomes plus. This plus anyway, this is also plus anyway. So 1 by 4a cos 80 common, e power 80 minus e power minus 80. Sin 80 can be taken as common, e power 80 minus e power plus, with the plus both terms of plus, e power 80 plus e power minus 80. And then from this fraction outside, I will take 2 inside, 1 by 2 inside. This becomes 1 by 2, 1 by 2 here, 1 by 2 I've multiplied here. 1 by 2 I've taken inside. 1 by 2a. So this is the exponential formula for sin h80. Sin h80 is equal to e power 80 minus e power minus 80 by 2. This is the formula for cos h80. Same formula but with a plus here, e power 80 plus e power minus 80 by 2. So I'll substitute sin 80 here, sin h80 here, and cos h80 here. So that I have 1 by 2 is cos 80 into sin h80 plus sin 80 into cos h80. This is exactly what we have over here. So that is exactly what we wanted to prove in the formula in the question 1 by 2a into this particular term. So that completes the problem. A slightly lengthy problem. Here we come to the end of this video. I hope you have understood the inverse Laplace transforms. Please go through the problems and try to solve them. Thank you.